I think it should be. It is. Hang on. No.
When we took away the square,
What did I do?
the epsilon.
No, hang on. So, 1 minus 2s is, what have I done here?
That looks right.
Well, I need this to be positive. Okay, why is this positive, by the way?
Is greater than s squared before we brought in the epsilon.
Yeah, we've got this, so this is greater than 0. So let me see. Hang on a second. There's some algebra thing here.
Don't you want s plus epsilon squared is less than a?
Yes, we do. Thank you, James. Yes. Right. Okay, there it is. Yes, that I knew something was not right. Yes. So what we're trying to do here is make s a little bit larger and still show that it's less than a. In fact, I knew something was not quite right here because I was struggling with the s minus epsilon. Okay, so what do I do? Yeah, so this is now a positive quantity.
Isn't it still a minus s squared on top though?
It is.
Okay.
So yes, I shouldn't have changed that one.
So is it s squared minus 2s epsilon, and then it becomes s squared plus 2s epsilon?
The plus is, this is now a, oh, that's a plus there, yes. I got to get all the pluses changed. This is actually the quantity when I expand it, this becomes this, and that's positive, yes, okay. So yeah, sorry about that, that should have been a plus. Okay, so then what I'm going to do is I'm going to choose epsilon less than the minimum of 1, and this thing here, a minus s squared over 1 plus 2s. And now let's just write it out quickly. It'll just take a minute. Okay, so I start with s plus epsilon squared. That's equal to s plus 2s epsilon plus epsilon squared, which is now less than. Now, see, I can replace my epsilon squared by an epsilon, and it gets bigger, right? So s squared plus 2s epsilon plus epsilon. And notice, right, I'm changing epsilon squared to epsilon. It's not equal, but it is, this is larger than that because I chose epsilon less than 1. And so then this is now s squared plus epsilon times 2s plus 1. And now, by my other choice of epsilon, I can replace epsilon by this number. But again, I get an inequality because epsilon is smaller than that number. So I get s squared plus the quantity a minus s squared divided by 1 plus 2s times 2s plus 1. Cancel, cancel. This equals now s squared plus a minus s squared equals a. Yeah, sorry about that glitch there. Next time, so here's the final calculation, and notice what I've done here, and sorry to go over a couple minutes because of that little glitch. I did my parallel argument, but I don't even have to think about the way the logic works if I do this. And then there's no question, right? Because every inequality points in the same direction. And there's at least one of these guys in there. So that means the left side is strictly less than the right side. And that's what I wanted to prove. I wanted to prove this. Okay, so